So it should be fun to do it. And our long-term goals for all this stuff is to be able to take a cross-site scripting bug and use that to do client-side attacks across a large group of users, leverage database access to get access to the local system. We've got lots of work done there already with Oracle, with MS SQL, with Postgres. Leverage our PHP and Java access to pivoting, that's already implemented today. And basically use the application bugs to attack the local server, use privilege escalation flaws to get root on the local server, and use that to keep kind of propagating out. One thing they're still working on is actually building sniffer modules for various web application frameworks. So for example, with PHP, we actually install a hook into the PHP app that captures every post request coming into it, captures the credentials and saves those back to us. So what we'd like to do is for things like the PHP interpreter and the Java interpreter, is actually hook the running web application framework and steal all the credentials coming into the platform and bring it back out again. So instead of just owning the platform and running a sniffer, we actually want to hook the application platform itself and take credentials as they pass through the web application. We really want to do a lot more integration with other tools out there. Of course, Nexpo is W3F because they're tied to Rapid7 at this point, but also Burp, also WebInspect, anybody else that wants to work with us, we're happy to work with. The biggest issue right now is so I started on this project of doing the import side a couple weeks ago, and what I found is there's very few web testing products out there that actually export anything you can import again. Most of them export like these giant HTML reports, which are for the most part worthless. Other ones export XML, but the XML is full of like these giant paragraphs of text that have embedded URLs and parameters that you can't just parse out easily. So what we really need is a standard language of defining here's what a vulnerability is in this web application, here's what the prerequisites are, here's what form it is, here's what the different types of vulnerabilities are, here's the prepend, the append to actually trigger it. The OWASP guys have done some work already on the backend database to store these types of parameters, but it's been pretty limited so far. That's what the Nitro database uses today, or at least partly uses today. I'd love to have a standard XML schema we can share between multiple vendors that defines what a vulnerability looks like in the web app space, how to exploit it, how to trigger it, and then use that as kind of a common data language across these tools. I'm guessing most of the commercial vendors won't play along because everyone likes their own format, but we'll do what we can on our side to make it happen. This is kind of what Metasploit did a really good job of is making exploits accessible to the everyday researcher who wants to spend some time on it. Enough examples, enough code, a really simplified interface. Even if you don't know Ruby, it's pretty easy to write a Metasploit module. There's just not that much code to them. The whole idea is to abstract away as much as possible so that people who aren't strong programmers can still write strong exploits. We want to do that with the web. We want to do the exact same thing. So if you find a really cool web app vulnerability, you can turn that into a module really quickly. That could be as simple as just taking your post request, sticking it into a form, and have it automatically generate a module for you. There's a lot of ways we can do it. We already have a template system like that for the RFI engine that we have in Metasploit today for doing remote file include, just basically substitutes the URL parameter for something else. But we want to go much further with that and take that to all web applications and all web application vulnerabilities. So whether it's SQL injection, cross-site scripting, whatnot, we want to be able to have a really standardized module format anybody can contribute to, and of course this goes back into the BSD license source code tree everyone else can download. So make it really easy for folks who discover web app vulnerabilities, especially in commonly deployed products, to quickly create modules for them without having to have the full expertise of being a Ruby programmer or otherwise. And of course, we want to make sure all the stuff that we generate is nice and evasive and bypasses all the crappy filtering technology out there that doesn't really do its job. So no offense to anybody who creates like the WAF guys aren't that bad. They actually do pretty good parameter parsing, but a lot of the folks out there who are doing things like IPS and AV is not designed to catch web pages. It shouldn't be. I mean, there's a particularly egregious case where an antivirus will actually detect a Internet Explorer attack. Like they detect the attack and they block it, and they're like, yay, we block it, we're awesome. Unfortunately, the files still get saved to the cache. Now, the next time the person opens the browser, it loads it from the cache, exploits them, gets a shell, and since it didn't load it from the web, the AV didn't hook it. So this is a wonderful case for a product that caught the attack and then didn't prevent it from getting exploited anyways. But the developers, swear up and down that they blocked the attack. And they did block the attack that time, and then when the browser starts up again, they're screwed. So this product is AVG, by the way. So when anyone's using AVG, look at how it handles caching. It's terrible. So what we want to do is make AV basically irrelevant for web testing because they shouldn't be involved, either for client side or for server side. They're not involved. For IPS guys, if you're trying to use an IPS to catch an incoming web attack, you're probably doing it wrong. The faster your product is, the less likely it is going to be able to do deep content, especially encoded deep content. So if someone's selling you an IPS product, they can tell you it has 10 bajillion gigabits per second. That thing's probably not going to be able to do a gzip decode on any incoming post. There's all sorts of fun things you can do with on the website. For example, if you've got an Apache reverse proxy from an IIS web server, you can use Apache evasion techniques to relay the attack to IIS, which will then parse it, gets parsed one way for Apache and a second way for IIS. There's all kinds of fun things you can do, desync IPS products. People actually stopped caring about IPS evasion because it kind of felt like kicking the crippled kid, and it got pointless. No one cared enough. They're like, yeah, we know he's crippled, stop kicking him. That was basically the approach to IPS testing so far. So anyone who's telling you that IPS can block web attacks, they still can't very well. They may be able to get it if it's a post URL or it's part of the GET request or it's a maximum length, but for the most part, there's so many different ways to do evasion on incoming GET request. Not to mention that for most web application attacks, you can make your users do it for you. You can actually make your victim target your other victim. So either through cross-site scripting or just doing like image source equal, HB:// at my target web server, question mark, my evil parameter. I mean, you can have your, send an email out that actually triggers a RFI vulnerability in someone else's site and make the users themselves do the attack from inside behind the firewall. So there's billions of ways you can do it. So don't put much thought in, and definitely don't depend on your IPS or AV products or filtering products to do much for you when it comes to web attacks. We need to work more on advanced server-side payloads, so we're working on things like the Cold Fusion platform. So right now, we can do that through Java. We want to do an actual CFM payload soon. Hook into the active web server process to steal data directly out of the web server itself. Egypt has our James Lee, one of our developers, has a really good approach for Apache right now, where PHP is dumb enough that it actually doesn't close. PHP is combined with Apache and certain threading models, like the process fork model, doesn't close the socket itself. So the PHP script that's running on the page can actually just take over the incoming WebSocket and become the web server. So, any PHP page can now take over all of the virtual host in your server just by hijacking the socket from it and handling a request. So kind of a neat request there. And then you can do cool things like rebinding attacks because the client thinks they're talking different VOs, they're really talking the same PHP script and all kinds of cool things. So we're looking at different ways to hook into the Apache process, the IIS process, and basically steal data directly out of the running process and hijack those. We definitely need to do more with client-side payloads. Those cross-site scripting payloads, like the beef-style sessions we talked about before, but we want to go further. We want to do things with Flash, and HTML5, and various callbacks. I mean, the HTML5 stuff is awesome for payloads. Someone wrote a reverse proxy that goes through HTML5 already. So the HTML5 will do a post back to them. They do kind of reverse request through the process. So there's all kinds of really cool things you can do with HTML5. And Silverlight, of course, if you allow .NET to run your systems. But at the end of the day, we want to be able to relay server-side attacks to your clients and actually get shells through them. For database payloads, we're already doing a lot of it right now with Oracle and MS SQL. We need to do a lot more. But the idea is we'd have a full-blown interpreter running as an agent within the database server itself. So your MS SQL process would actually be running a full copy interpreter running as PL SQL. Oracle, you'd have a Java payload running in memory, things like that. And if you've got a persistent payload running inside of your Oracle database process, you're basically screwed as far as getting that thing back out again. The only solution to killing that's probably going to be turning your database server off, which no one ever likes to do. So there's some different attack vectors there at the database level that are almost impossible to remove you from, and provide you access to things like database hooks. You can set up triggers so anytime a new user is created, it automatically sends you the password, things like that. So long term, we're really going to focus on database payloads going forward and do deeper database assessments. Be able to do a full search dump, modify the database remotely, doing pivots directly to the database structure itself, and of course things like injecting client-side attacks into the HTML stored inside the database tables, then relaying it back out. So the takeaway of all this is we're trying to find ways to take the stuff that we already have in Metasploit today and leverage web application vulnerabilities and leverage database injection vulnerabilities to go even further with it. And I'm out of time, so go real quick. We're looking at some password cracking integrations, both third-party tools as well as command line tool integration. So being able to crack all the MD5s that are weak passwords and reload those passwords through a different protocol or use it with a different exploit. The summary is we're really trying to take web application security seriously from now on. Before we've kind of dabbled in it here and there, we're finally putting a concerted effort to building it out, maintaining it, and actually building a first-class web testing platform going forward. And if you have any ideas for patches, for anything else, let us know. The first delivery is going to be mid-October, and love to see your help on it. So thanks again.